Okay. Starting with number 23. So I want to talk about the vocab word for this one first. And I want you to notice that B and 86 are both on the same side of the transversal. That is your big hint. They're on the same side of the transversal. And they're in the interior of the parallels. Okay, let me say that again. B and 86. Yes. Almost. Interiors in there. Shh. They're on the same side of the transversal and in the interior, Peyton? Same side interior is what these are called. Okay, and the question is, are these equal? Go ahead. Are they equal? 86 and B, are they equal to each other? They're actually not. So this guy, it's really hard to tell in this picture. It should be a better picture, but this is an acute angle because it's less than 90. And this one is an obtuse angle because it's greater than 90, which means that instead of being equal, they add to 180. Okay, so how we find it is we're going to say B equals 180 minus 86. And that is 94. Whose phone is that? It's okay. Right, number 24. What is the vocab word for this situation? We had it in our notes. Angle, yes, nice. Complementary. Not to be confused with giving somebody a compliment. Like, oh, Angles, you look really nice. Different kind of complimentary. Someone laughed. Someone out there laughed. Okay. Complementary angles add to 90. You can see the little 90 right there with the box. You're here. Tell it. 90 minus 54. Thank you. Yeah. Is 36. Okay, we are not done with the packet. If you could please find number 55. We didn't finish it on Tuesday. You're like, yes, we did, Mrs. Talbot. No, we didn't do the spicy ones. You guys could find a colored pencil, please. Doesn't have to be the same color as what we had on Tuesday. I'm going to use the same color, but you don't have to. Okay, so we're going to work on the spicy domain and range. I know domain and range is spicy on its own, even without the spicy ones. but believe it or not, they get harder than we did on Tuesday. So I wanted to save them for the beginning of today, where your brain was like fully, has not been bothered with anything yet, except for the poor people that had early bird. Okay, but, all right. We're gonna start with B. I see how there's arrows at the end of this line. So when I do the domain, I'm gonna say, okay, my line, and remember, when we're doing domain and range, we only color on the axes. You guys remember that? So we're coloring on the axes. Okay, so I notice this arrow is going forever to the right. And then the line is here and here and here. And it's also because of this arrow going forever to the left. That means our domain is everything. Do you see how the whole x-axis is covered with an arrow, both sides? Okay, when that happens, our domain is all real numbers. Okay, so when there's both arrows going both ways, all real numbers. Okay, now we're going to do the range. We're going to color on the y-axis. It's going up forever. Line is here, line is here, line is here. Down forever. Whole y-axis is colored. The range is also all real numbers. Okay. Move on to letter D. Now, letter D is, it feels, I want you guys to just extend those out. It really helps to see that those go forever and ever and ever. And it looks like they're going to start to go like straight down, but they're not. I promise you, this is going to go on forever to the left and on forever to the right. So on forever to the left. On forever to the right. Arrow forever left, arrow forever right. Domain is all real numbers. And you're like, oh, well, does that mean the range is all real numbers too? Not on this one. Do you guys see that there's a very clear top to this graph? Okay, so I find that very clear top to this graph. And I'm going to come over to the y-axis and make a dot there. I found the very tippy top and made a dot there. But it does go down forever. Okay, there's a very big difference between arrows on both ends and an arrow on one end. This one, we're going to say, what is the top of this, by the way? 4. So we're going to say y is less than or equal to 4. If you forget at all during the year which way is greater than or less than, I invite you to look at my adorable crocodile pictures up here all year. They will be there for you, just in case you forget which is which. Okay, but does it make sense that it's less than because the arrow's going down? Okay, one more and then we're done with this page. And this is probably the spiciest. If you notice up here in the backboard, Math 3 did a bunch of these on these posters back here. Okay, so domain. Here is the left. This is the very most left. I'm going to make a dot. So I find the very left of the graph, make a dot, and then I say, okay, and it looks like the arrow is going to go forever to the right. Okay, this is an arrow that's going one way. So we're going to say X is greater than or equal to 0. Do you guys understand why I put X for that instead of Y? Okay, now for the range, I found the very bottom of the graph. I made a dot. This is as far as this goes right here. And the arrow is going up forever. Okay, what is this bottom spot right here? Is that 3? Okay, so Y is greater than or equal to 3. Okay, so that was really Tuesdays, but now we're going to work on some more of them. So flip the paper over. We're starting to today's now. And before you get overwhelmed, we're not going to do all of these. We just can't because, we just can't do it. Okay, what I want you to do first, in your groups, I want you to take 30 seconds to a minute and just decide if it's yes or no if these are a function. So you see how it asks if it's a function? Try the vertical line test on these, or just from what you know about it being a function, and just answer the last question yes or no on each of these. Go ahead, talk about it. You guys remember how to do the vertical line test? All you're doing right now is just saying yes or no, whether or not they're a function. That's all you're doing. Don't worry about domain and range at the moment. I'm going to put the answers up in 30 seconds. Okay, here we go. Check your answers. First one is no. Second one is yes. Third one is yes. Anyone want to say anything about those? Do you understand why number one is no? No. Okay, so excellent question. I'm glad that you said something. If I drew a vertical line right here, how many times would I cross this? Infinite, right? Look at all of them. You can't cross it more than once. Are the other two okay? Okay. All right. Now moving on. I knew that one was going to be spicy. Okay. Yes. 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 Any questions about those three? Are you sure? Okay. Number 7. No. Yes. No. Any questions about those three? How are we doing so far? Okay. Last 3. Yes. Yes. No. Okay. Now we're going to go back up through just some of them and do domain and range. We can't do too much domain and range in one day. It'll like shut your brain down for the entire rest of your whole day. Like you just can't. We just can't do the whole page. I don't even want to do the whole page.
I don't have that. I don't have the powerful trait.
Yeah, no, that's not true. Whoa, 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 whoa. See, I think that that's wrong because I think you have an ability to think outside the box the way that I do not. My husband, super good at thinking outside the box. And sometimes I have a problem and I come to him and he's like, well, why don't you do it this way? And I have to tell you, I would go my entire life without thinking of a different way to do something. It is an extreme weakness that I have. For some reason, I'm just a linear thinker and I'm like, it has to be done this way because that's the way you do it. No. Mm-mm. Okay, anyway, so I circled the ones here that we're going to do. And there's some easy, some spicy. This one's on the easier side. So we're going to start with, I'm actually going to do some of this in pencil and some of it flare pen, but I'm going to use that same color pencil color that I was using earlier. And what I'm going to do is I'm going to mark the x-axis for the domain. And remember, domain is left to right. Here's the left, but it's really important. I want you guys to see this one has something new in it. It's got an open circle. Okay, so there's the left, and then it goes, and it goes, and it goes, and it goes, and it goes. And there's the right. So there's the left, there's the right. Okay. So my left spot is -5. And my right spot is 5. And it's domain, so I put X. Okay, this is the moment where something is different. This side, the -5 side is open, so I don't put the or equal to there. It's just less than. And then this side is closed, so I do put the or equal to there. Yes, honey.
I didn't put that number down.
Oh, you can just put dashes there. This one is too spicy for math 1. So all I wanted to do was that part. We're not going to do all of these. We can't. Just can't do it. Okay, now we're going to do the range. Okay, this is a big question. Super big question. Now that I have told you something about open and closed, the bottom is right here. Is it open or closed?
Open. Close.
Okay, it's a really good question. It's hard to tell. It's open right here. It's closed here, and it's closed here. If it's closed anywhere, it means it's closed. Okay, so what you're saying is to yourself, the question you're asking is, does it actually touch at -2 anywhere? Yes, here and here. Does it actually touch at +2? Yes, all along there. So here's my range. This one's closed on both sides. I zoomed in so far I can't reach it. Okay, that one's done. Does anyone have any guess, any intelligent guess for what the domain and range are for number 3? Think back to number 55. Yes, Landon? Yes. Domain is definitely all real numbers. What about the range?
Oh, no, I said the range.
The range is all real numbers and the domain is all real numbers, actually. Now, it doesn't look like this is going to go forever to the left, but I promise you it is. It's going to be really slow. It's going to get there super slow, but it's going to do it. Okay, on the next line, we're only going to do number 5. So you can put dashes in the spots for 4 and 6. We're only going to do number 5. Number 5 is just a list of dots. So for the domain, all we have to do is put the X values of those dots. So I'm going to put a dot here, 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 and here. Those are on the X-axis where those dots are. Okay, so X is -3, -2, 1, 2, and 5. Okay, you don't need that anymore. We can put that away. Range. So I have a dot down here. I had one on the X-axis. This is fun. I've got 2 of them at 1 and 1 at 4. When you're writing a list for domain and range, don't write it twice. So we have -5, 0, 1, and 4. Yes, honey. Yes. Do you see where the pass is? Okay. Moving on. Number 7. Number 7 is doable. This one's actually okay. Thank goodness. All right. It's not. Thank goodness. This is an easier one. So domain is left to right. There's the left to right of my circle. Do you guys remember how we write it when it's between 2 dots? It looks just like number 2 on this sheet. Take a look at number 2 on this sheet. So the left, the right, X, closed, closed. Why is it closed, Mrs. Talbot? Because it actually touches at that spot. Okay. Range. Bottom of the circle to the top of the circle. Bottom of the circle, top of the circle. Okay. What is the bottom? 1 to 5. Range is Y. Done. Okay, we're gonna do two more on this page and then we're done with this page. Pure excitement. Okay. I don't love this picture because it looks like these are gonna start to go vertical, but they're not. They're actually going to go out forever. So you say to yourself, is it gonna go forever to the left? Yes. Is it gonna go forever to the right? Yes. What is it called when it's forever to the left and forever to the right? All real numbers, beautiful. Okay. All real numbers. Okay, now this one has a very clear bottom of the graph, which is here. This is the bottom. And then it goes forever up. I think this is probably the hardest to do when there's just one arrow. Do you guys know the inequality for this arrow? I'll get you started. It starts with a Y. Is it greater than or less than? Greater than or equal to, and what's the bottom number? 0. That is super hard. Okay, you guys get to put dashes in 9, 10, and 11, so we're not doing those. We get to skip 9, 10, 11. It's going to be great. However, I want you guys to try number 12 on your own. I'm going to give you a couple minutes to think about it. This is a thinker, but it's kind of like the circle problem. There's your hint. I want you to try number 12, and then I'll put the answer up in a minute. All right, let's see. I am so curious. You do not have to say, but here is the answer. The domain goes, you don't have to say if you got it right or wrong. This is really hard. I know this is hard. It's okay. The domain goes from -3 to 3. X closed, closed. Anyone want to tell me they got it? Yes. Okay. Now, range goes from -2 to 4. Y in the middle, closed, closed. Are we sort of, kind of getting it? I know it's not perfect. I know it's spicy. You guys are actually, once you're done with this, you're done with your packet for the day. So you can put your packet away. Okay. Now, can you guys find your domain and range notes in your notebook? We didn't finish those either. After we finish these domain and range notes, we're just gonna take a mental break for a minute. And then we're gonna switch to something that's 1,000 times easier than domain and range, which is basic exponents. It's so easy, you might be bored with it, but that's okay, because we just did something really, really hard. And then don't forget, we have a quiz at the end of the period. It's in bold on your sheet there. Let's go. But it shouldn't be bad. Function machine, solving equation, and something else. What was it? Function machine, solving equation, and something. Anybody remember? No. Oh, what, saying whether or not a graph is a function. No domain and range on it though, just yes or no if it's a function and then the vertical line. So what we did at first on the paper, not the, you guys are not ready to be quizzed on domain and range. That is absolutely okay. All right, so this first one, we're gonna do the same thing we've been doing. So this one here is one of the spicy ones. And this one is not spicy, but I wanted to talk about what this thing is real quick, just in case anybody did not come from Benicia Middle School. So this one, this arrow is going forever to the left, so I'm gonna make my domain arrow go forever to the left, and then forever to the right. I actually said something that made sense, but on accident. Domain error is a thing, but I meant to say domain arrow. Oh, I'm hilarious. Okay. There's other things that are domain errors too, but that is the most common one. Okay, so domain, forever to the left, forever to the right. So all real numbers. Okay, so now the range. This is the bottom right here. So I'm going to put a dot there at the very bottom. And it goes up forever. So this is one of those where it's just an arrow on one side. So we just write a regular inequality statement. Y is greater than or equal to -2. Okay, so number 4, example 4. Do you guys know what this thing is called? Anybody remember? What is this thing? It starts with an M, ends with an apping, rhymes with napping. It's called a mapping. Have you never seen a mapping before? Has anyone seen a mapping before? Okay, one person. Well, I'm really glad we're doing this then. This is the same thing as a table, but it's got arrows telling you what goes with what. So if you look at the top of 3, the arrow goes to the 1, so that's the coordinate 3, 1. And then the next one is coordinate 7, 5, 6, -1, 5, 6, and 2, 0. So it's just in a different order. And the arrows tell you what goes with what, like what X goes with what Y. Tomorrow when you guys are in class, by the way, you don't have weekend homework over your long weekend, which is great. But tomorrow in class, we're doing a domain and range scavenger hunt. I'm gonna hang all of these clues around the room, And then you have to find the domain of the, or range of one of them, and that leads you around the room. Anyway, there's mappings in that, so I needed to talk about this today. First question I have is this a function? Yes, there are no repeating x's. Each x has its own separate y, so this is a function. The domain, though, is very easy. You just list the numbers least to greatest for the x, so we could put x and y here. So 2, 3, 5, 6, 7. And the range is y, -1, 0, 1, 5, 6. Mrs. Talbot, I don't hate those domains and ranges. Yeah, I know. Those ones aren't terrible. Okay. Now I need you to just put everything down. Once you got that, just take them, just do nothing for a second. Mental break. So take this home sheet here and put this in. You can recycle it if you don't want it anymore.
I can take it.
Or you can take it home and put it in your completed papers.
So I'll put it in the folder.
Okay, perfect. Okay, we're doing nothing right now. You're just relaxing for a second, letting me do all the work. Okay, this is what we're doing today. It looks like a lot. We already did the domain and range worksheet, so we can check that off. These exponents and scientific notation things are very easy. Very, very easy. You guys know, like, x to the fifth is x times x times x times x times x. If you know that, then you already know this whole lesson pretty much, but we have to review it. This is not going to take us very long, and then we're going to do the quiz at the end. I'm thinking 15 minutes is plenty. Homework up here is 68 to 70 and 72. And there's my joke for the day. It says homework. What are you doing? Homework. Stop. It's piling up. Yes. Yeah. So when you see it look like this, these like 1- problems, those are on CPM on Clever. Okay. Last thing I want to do before we start doing math stuff again is I want to show you this. This is a grade level report of math test grades. I gave you your math test scores back on the paper. And most of you guys got in like the 12th grade range. I was really impressed. This class did really, really well. I was super excited. You want to look at this column here. So 233 or above is like the average. So this is everyone. It's, you got to imagine, it's everyone that takes this test in the 12th grade, everywhere. So this is like their average in the fall. And so the average of 11th grade is 231. The average of 10th grade is 229, and the average of 9th grade is 226. So if you guys are in 9th grade and you got above 226, that means you did above average, which is great. So I just wanted you guys to know that. I think most everybody did really well, and I was really happy about it. So you should be happy. Now, if you got a positive stapled onto your math test results, it's because you stayed above the 80th percentile, so you're in the blue, or you went up more than 5 points from your last round. So if you went up more than 5 points or stayed in the blue, you got a positive from me. Okay. I want to show you guys something on the report that's really important. this is really, really good. Like super good. This, the part that you want to look at on your report is this part right here. So this is the part. So when you take that number and you say, okay, 76% of people did the same or worse than me, is what you should say to yourself when you see that number. So the achievement numbers, that's a percentile. And so you say, okay, I did better than 76% of people. That's really, really good. Super good. So I'm really impressed. And you can see your growth on the back if you have taken this before. So there's a lot of tests on here, but I want you guys to think about something interesting that Miss Rice and I were talking about. Her son took the math test last year in first grade. Stop. Knock it off. Down. No touchy. Turn. Okay. And think about if he takes it 2 times in first grade and he takes it 2 or 3 times every year, what is little his little graph gonna look like when he gets to be your age? See how many tests you guys have? It's gonna be like the whole page. So I think it's really cool that you can follow somebody's score all the way from like kindergarten through 12th grade. Really, really cool. Okay, back to math now. You guys could start writing these two down. That would be great. This is going to be very easy, I promise. I am going to do these problems in 2 colors. So if you are somebody who likes to have a colored pencil or something, likes to color these, then definitely having your colored pencil from your domain and range will work here too. Also, I have a colored pencil sharpener. You already know it. People already know this, I see. Okay, Now you're going to be mad at me, but I'm going to make you write them out today. Today we're gonna do it. See, if we don't tilt the chair like that every 3 seconds, it doesn't happen. So we're going to write them out. We're going to write them in expanded form. We're not going to write them in expanded form every day. We're just going to do it today because I want to make sure that everybody is completely clear on these. These do not stay as easy as they will be today. So this is like dipping your toe in to the pool of exponents. Okay. 64a, y to the 7 times y squared. 1, 2, 3, 4, 5, 6, 7. So there's y to the 7 times y squared. 1, 2, 3, 4, 5, 6, 7 times y squared. How many total do I have? Y to the 9. Okay, now you're like, this is tough, but I can see that that's y to the 9 without making my hand fall off, making a million y's. Yes, I know. Just doing this today. We're not going to do it forever, I promise. Okay, letter B. I wanted to remind you here that the cubed part is only on the part with the parentheses. So this is 5 times 2m times 2m times 2m. So the 5 only happens once, but the thing in the parentheses happens 3 times. Okay, what's 5 times 2 times 2 times 2? Beautiful. And how many m's do I have? 40m cubed. Okay, C, x cubed squared. I'm going to do this in 2 steps. First thing I'm going to do is do x cubed times x cubed, because I'm showing that I'm squaring. I'm multiplying it by itself. And then I'm going to say x cubed is x times x times x. And then this x cubed is x times x times x. Which gives me a total of 6. How are we doing so far? Okay, last one. 4 times x times x times x times x times x times y times y. So there's 4 x to the 5th y squared times x times y. Okay, the only number there is 4. How many x's do I have total? 6, beautiful. And how many y's? 3. Okay, so this is your little reminder. If something does not have an exponent on it, that means there's a little 1 that we just don't write that's always hidden there. So you have to remember that those are to the 1. Okay. What? Okay, why am I putting that? Because I can go straight, if I know that, I can go straight from here to here without writing it all out. Okay, any questions about number 64? Are we good? Okay, now 65. 65 increases the spice level a little bit. What we're looking for in number 65 is giant 1s that we can cross out. So there is a giant 1 right here. X divided by X is 1. I'm going to show the giant 1 by canceling out 1x in the top and 1x in the bottom. So this is 1 times x times x. Do you guys see where I got the 1 from? And then x and x squared. B, x times x times x times x times x times y over x times x. Okay, question is, do you see any giant ones that I can make? Yes, how many? 2, beautiful. Guys are geniuses. Okay, so this gives me 1 times x times x times x times y. Like Mrs. Talbot, I don't need to write that step. I know, but someone in here might like it. And that is x to the 3rd y. Okay, pause real quick. Does anybody see how I could get x to the 3rd y without any of this stuff? How?
Then you do that subtraction.
Yeah. Exactly, yeah. Okay. So k to the 3rd, k times k times k times k to the 5th times k times k times k times k times k. I sound like the guy from South Park. Okay, 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 okay. Now I've derailed your brain. Okay, on the bottom, okay, I have k times k. Giant ones, how many? 2. Oh no. Oh no. Oh no. Oh no. There we go. Okay. Last one of this type. 16 times z times z times z. 8 times z times z. Okay, giant ones, anything? 2 z's, beautiful. Great job. Okay. So I have 16 z over 8. And now you transport yourself to 4th grade and you say, okay, 16 over 8 reduces to 2 and 1. 2z. Right, guys, you know how to do 66A already? Do you know how to do it without writing it all out? Okay, so what I like to do for this one, I'm just gonna put a little baby one there in a different color because I want it to show that it was not in the original problem. I say I have 3 H's and 4 more H's and another H. How many H's total? 8. Done. Okay, now we're gonna skip to D. I know it's weird, but D is the next easiest one. 8, yes. And for your colleagues here, just going to show my work like that. However, if you notice that those two can be multiplied, that's what we're doing on Tuesday. Okay, now move to C. C is a little bit spicier because you're going to see giant ones, but it's really important that we talk about this. So W times W, W times W times W times W times W. I don't have a funny thing to say about W. Okay, now it's easy to see giant ones, right? Do you see it? 2 of them. And then the problem with this one is that half of your class is going to want to write equals W to the third. That's the wrong answer. The answer to this is not W to the third. Nope. It's not that either. It's 1 over W to the third. Okay, why is it 1 over W to the third and not just plain W to the third?
Try to repeat what you get at one or W. One and W is the same thing.
Well,
You can just put W and W to nothing.
what? Well, W can be anything because it's a variable. Okay, but you know how I make giant ones here? And you see how the whole top canceled out? So there's nothing left on the top? That's kind of not true because these are ones. So there's a 1 on the top. You see what I mean? We canceled them out and made them into ones. So there's a 1 up there. Now, I think what Dylan's trying to say is, I think he's saying, I noticed there's 5 on the bottom and 2 on the top. So if I cancel them out, there's going to be 3 left on the bottom, which is great. Okay, last one. This one we can do fast. What's 39 divided by 3? 13, beautiful. And if I have 4 P's on the top and 2 P's on the bottom, how many P's will be left over? 2 after I cross them out. And if there's 5 Q's on the top and 2 Q's on the bottom, 3. There's 7 total, but you're going to cross 2 of them out. Okay. All right, so we're going to take this and we're going to apply this to this. What are you guys doing in physics right now? Is it V equals R times C equations? Physical science? Are anyone doing physical science? Physics? You're not? Oh, but it's different teachers though. They do different order of things. So This number 67 and the notes we're going to do after this for scientific notation are not really for math class, it's for science class. Have you seen scientific notation numbers before? Okay, so the reason that we put them here is because they have exponents in them, so they follow the same rules as regular exponents. So what you do for this is a division problem. You take the front numbers and you do 12 divided by 4 times 10. And then because it's division, you subtract the exponents. So you take the front numbers and divide them and subtract the exponents. Twelve divided by 4 is 3. And 9 minus 3 is 6. All right. Last one for 67. I'm going to actually write this twice. Okay, and what you do is you take the two front numbers and you multiply them this time, because this is a multiplication problem when they're like right next to each other. And then you add the exponents. I just added them in my mind, but I didn't really want to add them yet. Okay, but this problem is not done. We want it to be done real bad, but it's not. Scientific notation, the number in front has to be between 0 and 9.9 repeating. This number is too big, it's 64. Have you guys ever done this before? Middle school, no? Never seen scientific notation before in your life? Okay, so what you're supposed to do is you're supposed to take the decimal after 64 and you're supposed to move it here. So this becomes 6.4. And then because you move this down a spot, you add 1 spot on the exponent. Okay, we're not done yet. I have very quick notes to do on this and then we're done. Okay, you guys, I need to go relatively quickly here so we can start your quiz. I'm so sorry.
Oh, no, you're fine.
Okay, so standard form, maybe this looks familiar. Standard form to scientific notation, you put the decimal point where it goes, and then you move the decimal point until the number becomes between 1 and 9.9 repeating. So I'm gonna go 1, 2, 3, 4, 5, 6 spots. So this becomes 5.32 times 10 to the 6. Did that look familiar at all? Nothing? We have nothing? Never? This is solid? This is just making stuff up over here? Okay. This one, where should I move the decimal to? Between what two numbers? The amount of moves I did. So 1, 2, 3, 4, 5, 6. Okay, where should I move the decimal in this one? In between what two numbers? 3 and 7. 1, 2, 3, 4. Does anybody know what's different about this one? 3.7 times 10 to the -4. Because on the first one, I had a really big number and I made it smaller. And on the second one, I had a really small number and I made it bigger. Okay, I'm going to tell you guys to pause on this. We'll finish this later because I want to make sure everyone has enough time for their quiz. So just leave a little bit of room for me here.